One of the nice things about the mean value theorem is that we can use it to show some really important facts in calculus. So one of those important facts is that if f and g are differentiable with having the same derivative, then f of x has to equal g of x plus c for some constant c. Now, you might think that you could show this just by taking the derivative of each side, maybe noting that the constant goes away, but what that's doing is that's kind of starting with our end and proving our beginning. We want to start with our beginning and prove our ending goal. So what we're going to need to do is actually use the mean value theorem. So first, we're going to do a little proof here. First, let h of x equal f of x minus g of x. We'll just start by doing that. Then, if we take the derivative of h of x, we get that the derivative of h of x equals f prime of x minus g prime of x, but those are the same thing, so this is just going to be 0. Okay, so we did that, but I'm promising you that the mean value theorem will play a role here. So let's go ahead and look at the mean value theorem. Now, let's pick two values, a and b. And let's just plug them into the mean value theorem. Since h is differentiable, there is some c between a and b such that h prime of c equals h of c, or h of b minus h of a over b minus a. Well, what this tells us is h prime of c, no matter what c is, that has to be 0. So this is going to be 0 equals h of b minus h of a over b minus a. We're assuming that b minus a, or that b and a aren't equal, so b minus a is non-zero, so we can go ahead and multiply both sides by that. So we're going to go ahead and get 0 equals h of b minus h of a, which then gives us that h of a equals h of b. What this tells us is that we picked any two values a and b that we wanted. What this tells us that h of x is a constant function. So we can write h of x equals c. Because again, we just showed that no matter what two values you pick, they're going to have the same output. That's exactly what a constant function does. So we use the mean value theorem, and now let's go back and look at what we said. Well, we just said that h of x is a constant function, but what was h of x? Now, h of x equaled f of x minus g of x, which also happens to equal some constant c. So now we can ignore this h of x part and just look at this. If you add g of x to both sides, you're going to get exactly what we wanted, that f of x equals g of x plus c, which is exactly what we wanted to prove. This is going to be important later on in the class when we look at antiderivatives. Basically, when we look at antiderivatives, I'm going to give you a derivative. I'm going to ask you what was the original function. And if I give you a derivative, there are lots of different possibilities for what that original function might be. But what the mean value theorem tells us is that no matter what different antiderivatives we have, they all just differ from each other by some constant. So it's good enough to just pick your favorite antiderivative and then add a plus c, because then you can get to any other antiderivative just by modifying the constant appropriately. So it's the mean value theorem that allows us to describe all the antiderivatives for a given function in this way.